everybody, welcome to Mrs. Baker's Chemistry Corner. This is Module 5 Monster Paper Walkthrough for Paper 4, and it is question 5. So let's have a little look at what we've got going on here. We've got calcium chlorate. It's made by reacting calcium hydroxide with chlorine gas, and it gives us a balanced equation. It says that 8.8 grams of calcium hydroxide and 7,200 centimeter cubed of chlorine gas are mixed together. Now, straight away, our brain goes to say, oh, I think this is going to be about limiting reagents. Why do we think it's going to be about limiting reagents? Because it's given us two amounts in the starting lineup. And if there's two amounts in the starting lineup instead of one, then usually they're going to ask you to find one of them has got more moles than the other, and so they're going to ask you about limiting reagents. But let's have a carry on reading through the question. First of all, it's asking you how many moles of calcium hydroxide do you have? Then it's saying how many moles of chlorine do you have? And then it's saying what's the maximum number of moles of calcium chlorate. So we are talking limiting reagents here. So we're going to need three things in our table. So let's go ahead and draw our table out first. Let's say we've got 6 calcium hydroxides. We've got 6 chlorides, or chlorines, sorry. And we've got 1 calcium chlorate. So we know that we've got grams here. So we know we're going to need our mass, mole, MR triangle. And we also know that we've got a gas because we know that chlorine is a gas. We know that, but it also tells us that in the question here. So we know that we're going to be up here in our vol-mole 24, our gas triangle as well. So we've got vol and 24. So we can go ahead and put the lines in our table so we don't get confused with anything. All right, now we're good to go. So let's put in what the question tells us. The question tells us we have 8.88 grams of that. It tells us that we have 7,200 over 1,000. Remember, we need to put it into decimeters cubed. And that's all that it tells us at the moment. So the first one is how many moles of calcium hydroxide do we have? So we're here. We've in this mass moles MR triangle here. So we need to work out the MR of calcium hydroxide. The MR of calcium hydroxide is 40 added to 2 hydroxides. So hydroxide is really easy to work out. It's just 16 plus 1, which is 17. And we've got 2 of them. Let's do that in our calculator. So we've got 40 plus 17 times 2 gives us 74. Now that we've got the MR and the mass, we know that we can do 8.88 divide by 74. Let's do that. Divide by 74. That gives us 0.12 moles of that. Now, we could say, well, then we make 0.12 moles of that, but that's not the case because it's already told us we've got 7,200 centimeters cubed. So in this case, we need to work out how many moles of chlorine we actually have. So we do that by doing 7,200 divide by 1,000. That gives it to us in decimeters. That gives us 7.2, and we just times that by 24. No, we just divide that by 24. I apologize because it's volume divided by 24. Thank goodness for the triangles up there. 7.2 divide by 24. That's why it's always a good opportunity to draw your triangles out when you get a mole calculation. So we've got 0.3 moles of that. Well, clearly we can see then that our chlorine is in excess. We know this is in excess. We know this because 0.3 is a much bigger number than 0.12, and we've got a 6 to 6. So fundamentally, we've got a 1-to-1 ratio here. So this is in excess, and our calcium hydroxide is our limiting reagent. So now we know that we can pull across our moles from the calcium hydroxide, not from the chlorine, because chlorine's in excess. There's no way we can use up all that 0.3 moles. So if I want to find out my moles of calcium chlorate, I just take my limiting reagent, which is the calcium hydroxide, and I look at the molar ratio between that and the calcium chlorate. So I have a 6-to-1 ratio. So I have 1/6 of the amount of calcium chlorate than I do of calcium hydroxide. So I've got 0.12 moles of calcium chlorate. If I divide that by 6, calcium hydroxide, if I divide that by 6, I get 0.02 moles of calcium chlorate. Now, if I've got 0.02 moles, then I know if I want to find the mass, I must times it by the MR. So let's have a little look at what the MR might be of calcium chlorate. Well, we've got 40 added to 35.5 times 2 plus 16 times 6, because there's 3 times 2 oxygens. Let's put that into our calculator. So 40 plus, open brackets, 35.5 times 2 plus 16 times 6 equals 207. Now I can times that by the number of moles I've got, which is times 0.02, and that gives me 4.14 grams. So now all I have to do, as always, is take what's in my magic triangle and move it across into my question. So how many moles of calcium hydroxide do I have? I have 0.12 moles. How many moles of chlorine gas? I have 0.3. What's the maximum moles of calcium chlorate I can make? 0.02. And what's the maximum mass of calcium chlorate? 4.1 grams, 4.14 grams. So hopefully that makes perfect sense to you now that you understand how to work out the limiting reagent. So for the last part of question 5, it says the experiment is repeated using different amounts of calcium hydroxide and chlorine gas. The maximum mass of calcium chlorate that can be made in this experiment is 4.84 grams of calcium chlorate, and the actual mass is 3.63. So we need to calculate the percentage yield. So we do what we actually had, 3.63, out of what we possibly could have, which is 4.84, and then we times that by 100 to get it into a percentage. So let's try that. We do 3.63 divided by the possible 4.84, and then we times that by 100 to get it into a percentage, so it would be 75%.